let's start with the next method, the next way to apply inventive principles. So we are still on the method of applying inventive principles as were identified by Altshuler. And the next is using physical contradictions. So last time we looked at technical contradictions. What is technical contradiction? Can someone remind me? What is a technical contradiction?
So can I give an example?
Yeah.
So technical contradiction, let us say in op-amp can be like voltage gain bandwidth. Like let us say I want to improve, gain bandwidth, like which is constant for op-amp. So let's say I want to increase gain, so bandwidth will be decreased. If I want to improve bandwidth, gain will be decreased. So it is a kind of trade-off in between the two.
So yeah, thank you, Shanvi. This makes sense. Anyone else who would want to refine this further? Give another example or refine the definition further? Your definition is right.
Contradiction as in like in memory design or circuits, if we want to improve one parameter, the other parameter degrades. Or so they are contradictory to each other. If we increase one thing, or for example, the speed, the area decreases or something like that.
Yeah. So not just in memories, anywhere. The contradiction means that there are multiple parameters that are associated with any product. As you try to improve one parameter, another desirable parameter starts to degrade. So you have to kind of, as an engineer, you just optimize. And then what does the technique? Yeah, Soumyadeep.
Like we had that in bicycle chains, right? Flexibility and rigidity both.
Yeah. So what do you want to do then? You would want to, so how does technical contradiction matrix help in such cases? What does it do?
Basically, based upon the methods, based upon the problem which we are facing, it provides us 2-3 ways in which it can be improved, like methods in the sense like segmentation or other methods which were proposed by Altshuler.
So they were not methods, Shana, they were inventive principles.
Yeah.
So he listed down 40 inventive principles after he studied those more than 2 lakh patents. And of those 40 inventive principles, which were most commonly applied to solve this kind of a contradiction? That is what he lists down. So now what you do is, instead of now looking at a big space of 40 principles, you're only looking at which one of these 3, I just need to apply 3 or 4 of them. So your overall effort gets reduced. So that is the benefit of applying technical contradictions. Is using technical contradiction matrix easy or difficult?
So easy, I think, because we have 2 parameters, one on row and one on column, and then we find whatever the cell value is, and there are 2 or 3 ways, and out of which we can find which will work the best for us.
Yeah, so it's very easy because the situation that you have at hand, you simply need to talk about it. If I do this, then this improves, that degrades. That is all you need to do. You just need to formulate the problem in such a way that you talk about, if I do this, then this improves, that degrades. If, then, but. That is the format that we talked about. So that was the specific technical contradiction. How do you convert it into generic or typical technical contradiction? What is a typical contradiction? So Shanvi gave a contradiction. She said that if I increase some transistor size, the gain of the amplifier increases, but the bandwidth reduces. This is a specific contradiction. How do you convert it into a typical contradiction? What is the difference between this specific contradiction and the typical contradiction?
Sir, one contradiction, like we are talking in general that when gain increases, bandwidth decreases and vice versa. Specific contradiction is in a particular case. Let us say that I'm using this particular circuit and in this I see that kind of trade-off. So is it like that?
So gain and bandwidth is a specific contradiction. What would be the typical contradiction associated with this?
So like working can be improved only till a certain degree, let's say.
Contradiction has to be if then but format.
Oh, yes, sir.
What would you do? Yes, Shaina.
So basically formulating it in the form of like the general cases like stability, in terms of stability or something.
Talking of it in terms of the generic parameters, the 39 parameters that Altshuler had listed, so that you could directly go to the technical contradiction matrix and apply it. So until your if then but statement does not contain like the then and but thing, they're talking about the generic parameters for which the matrix is available. You are in a specific matrix. So gain, bandwidth, are they the parameters on the X and Y axis? No. So you convert that gain and bandwidth into something which is one amongst those. And then it becomes a generic contradiction. So do you realize that your specific contradiction can be converted into more than one generic contradictions? Is it possible?
Yes, sir, I think.
Because you're laddering up, you're going up the level of abstraction. You could go in this direction, you could go in the other direction also.
Yes.
And do you also realize that many specific contradictions may have the same generic contradiction?
Yes, sir. Yes, sir.
So for your technical, for your specific contradiction, there could be 2 or 3 different ways, and therefore in total you may want to apply 6 or 7 inventive principles. You may end up applying 6 to 7 inventive principles to solve the problem at hand. Okay. Any questions still here? This was what we did in the last class. Great.